Alright, so in this video we are going to talk about abstract classes, as the title reads over here, and this is the agenda for this video. Alright, so first we're just going to talk about abstraction, because it helps understand abstract classes better, and then we're going to look at the syntax and a full example on Eclipse to get the full gist of abstract classes. Alright, so earlier we looked at interfaces, right? And for most part, interfaces are nothing but a collection of method signatures, right? So they have the method name, but they don't have the implementation, right? And I'm going to pull up such methods, right? So this is the kind of methods that interfaces have. So they just have the name of the method or the signature, but no implementation. And these kind of methods, give me a second. I don't know why I did that. Okay. Yeah, so these kind of methods are called abstract methods, right? So abstract methods are nothing but methods that have a signature but no implementation. And similarly, abstraction is basically having the what but not the how. So because over here the method, you know what the method are, but you don't know how they work because you don't have the implementation. And similarly, abstraction tells us what functionalities are available to us but not how they work. That's the basic concept of abstraction. Now coming to abstract classes, right, they fall somewhere between normal classes and abstract and interfaces, sorry. So they fall between normal classes and interfaces because they do everything that a normal class does, right? So they have instance variables, they have fully implemented methods and all that, but they can also have abstract methods, right? So they can also have, one abstract method, two abstract method, all abstract methods, right? If they have no abstract methods, then they should just be like a normal class. There's no point in making it an abstract class. And if they have all abstract methods, then they most likely should be an interface. But yeah, so they abstract classes, right, can have abstract methods, right? So that's basically what abstract classes are. Now there are a few key points about abstract classes, and I'm just going to paste it here. It looks like a lot, but it really isn't. The first one is pretty straightforward. So if a class has even one abstract method, it has to be declared abstract. And that's, I guess I don't need to explain it. That's basically the gist of abstract classes, right? The second one is a little confusing, but will clear up when we discuss the full example. It'll make more sense then. But so basically, you cannot create an instance of an abstract class. What you can, however, do is you can create an object, right, and you can have an abstract class over here, right? So the object would have all the methods that are available under the abstract class, but the implementation of those methods, right, will be dictated by the child of that abstract class, assuming that the child is an abstract itself, right? And if you think about it, that makes sense, because if you could create an instance of an abstract class, right, then what that would mean is when you call an abstract method, right, like if you do object name, right, dot abstract method, right, if you try to call an abstract method of the object, right, assuming you created an instance of an abstract class, it wouldn't work because there is no implementation for that abstract method. That's why you cannot create an instance of an abstract class. What you can, however, do is you can have the abstract class name over here, right, so you can point towards it, right, but over here the instance needs to be of its child class, assuming that the child is an abstract. So that might sound very confusing right now, but when we do an example, that should make more sense. And that leads us to our next point, which is if you want to use an abstract class, you need to have a child class. Since you cannot instantiate an abstract class itself, you need to have a child class, so that you can point towards the abstract class, but you instantiate its child class, if that makes sense, right? Because if you don't have a child class, then the abstract class is pretty much useless. It's actually completely useless. So yeah. And the fourth one is when you inherit an abstract class, right? So if you have a class extending the abstract class, that class, right? So over here I have the syntax for extending, right? That class has to implement all the methods, all the abstract methods inside the abstract class. Once again, this is assuming that this class, the child class itself, is an abstract, right? So if this child class extends this abstract class, then it has to implement all the methods inside all the abstract methods inside the abstract class. So those are the key points, and these two will make more sense when we do the full example, hopefully. So yeah, let's get to the syntax and full example on Eclipse. Okay, so I'm going to start off by creating a new project. So new Java project, and I'm going to call this project abstract classes. And first I'm going to show you the syntax real quick on how to declare abstract classes and methods. It's really simple. So I'm going to call the syntax, right? And you can either check this box, or if you forget to do that, you can just put abstract between public and class. It's as simple as that. And same goes with my method. So let's do public abstract and then the return type, which I'm going to make void, so it returns nothing. And I'm going to call this abstract method. Abstract, okay, that's not right. Abstract method. And there you have it, voila. And you can also have non-abstract methods and abstract classes. So public void non-abstract method, and of course you have to provide the implementation for this. So I'm not going to provide any implementation because this is just for demonstration, but yeah, that's where your implementation will go. So that's it. That's the syntax. You put abstract between public and void in the method, and public and class for the class. So now let's start our example. So I'm going to create a new class, and for the example I'm going to have one abstract class, and I'm going to have a child class of that abstract class, which will not be abstract. So this abstract class I'm going to call graphic object, and I'm going to check this box here. And the reason I'm using graphic object as abstract class is because of how vague the term really is. Now graphic object can mean a square, a circle, a triangle, a rectangle, even 3D objects like sphere, cylinders, and all that, right? And if you think about it, graphic object, the attributes of it is different from shape to shape. So like a square has 4 sides, sorry, and a triangle has 3 sides. And a sphere, well, I'm guessing it has 1. I'm not really sure. For math geeks out there, you can correct me, but yeah. And you know, a cylinder has 3 sides, a rectangle has 4 sides, you know, a sphere is 3D, a square is 2D. So you get the gist that, you know, in graphic objects, the attributes for each graphic object is different from other graphic objects, right? That's why I'm using graphic object, because making this abstract makes a lot of sense. And so because some methods will be abstract and some will not, and we'll see that in a few seconds. So I'm going to say finish, and for graphic object I'm going to have abstract methods and non-abstract methods, and I collected a list of them when I was planning. So here are a list, Command Shift F. So for the abstract method I made draw object, because the way you draw an object is different, you know. The way you draw a square is different than the way you draw a triangle, right? Think about it, like if you take a paper, right, and a pen, and you were to draw a square, right, or you were to instruct a child to draw a square, your instructions would be different for a square and they would be different for a triangle, right? And same with print number of sides, right? For a square you would say print 4, for a triangle you would say print 3. And then this is just, it's very, you know, far-fetched, but I had a third example just to get my point across. So split across axis of symmetry, that basically means cut across axis of symmetry. A scaling triangle has no axis of symmetry, so you know, you would be like, okay, don't split. But a square has 4, so you'd be like, okay, split horizontally or split vertically, right? So these 3 differ from one graphic object to the other, and that's why they're abstract, because at this level I cannot provide the implementation, because the implementation is different for, you know, each graphic object. These, on the other hand, right, the implementation is the same, right? So color object, if you think about it, if you were to instruct a child to color a square with red, it would be the same instructions as to color a triangle with red, right? Because you just be like, yeah, okay, move your pencil back and forth and make sure you don't, you know, color out of the lines. So the instructions would be the same regardless of what object you talk about. And that's why this is non-abstract, because we can provide the implementation at this level, at the graphic object level. And same goes with enlargement, right? So if you think about your phone, when you zoom in, right, it doesn't matter what you're zooming in or what page you're zooming in on, right? You just pinch your fingers to zoom in. So the implementation is the same, right? And duplicate object, same thing, right? Rotate object, it doesn't matter whether you're rotating a square or a rectangle, right? You just, rotate. Like if you, like, I guess on Adobe Photoshop or Sketch, or those photo editing apps, when you say rotate, doesn't matter what the picture is or what the object is, the rotation feature stays the same, right? The implementation is the same, and that's why all these methods are non-abstract. Same goes with translation. Doesn't matter what the object is. The instructions to translate an object is going to be the same regardless of what object you're talking about, right? And these two actually, I don't think we need these. We don't need getters and setters. It'll just make it more confusing. So we have abstract methods and we have non-abstract methods. So I'm going to just comment these out because they're in the right format. The reason I didn't, type it all out is just to save time. And yeah, and it's pretty straightforward. You put the abstract between public and void, or public and whatever your return type is. So if this was int, then it would be, it doesn't matter what the return type is. You put it between the public and or private and the return type. And for non-abstract, I do have to provide implementation. So I'm just going to say sys out, and I'm just going to say coloring the object. And let's copy this because I don't want to type it all up just to, just because I'm lazy and I want to save time. And here I'm just going to say enlarging the object. And here I'm going to say, actually, duplicating the object. Oh, not duplicating, duplicating. And here I'm going to, what am I doing? Sorry, my bad. I did command and some other key. Sorry, command V, right, to paste. And here I'm going to say rotating object. It's really just the same. I'm not providing actual code on how to color the object because that's not the focus here. And I have two brackets here, and I'm going to say translating the object. Originally I was going to say translating the object to coordinate x and coordinate y, but it's unnecessary. It's that's not the focus here. We don't have to be precise. I think this should be enough. Right, so we've created the graphic object class. I don't have any instance variables. You can, but I don't have any just because I want to, keep it simple. I want to get the main point across about abstract methods and non-abstract methods. And now what we're going to do is we're going to create a child class. So my child class is going to be a square. So a square, and I'm going to say the square extends graphic object. Right, and so it gives you an error, and this is a good thing because it says add unimplemented methods. And the thing is, you just hit enter and it shows you what all methods you have to implement. So that's very convenient. And I'm just going to get rid of these comments or to-dos. And for draw object, I will just say sys out drawing the square. And for print number of size, I'll say sys out a square has 4 sides, right? And then split across axis of symmetry. Now here, right, a square has 4 axes of symmetry. So we need to specify which axis of symmetry we're talking about, right? So I'm going to have a string, and I'm going to call this axis. And what I'm going to do, this might seem a little overboard, but I'm going to have a string axis. Actually, no. Should we? Yeah, we can't have that. Sorry. I'm going to have a string axis here, and it's going to be private. We should never have public instance variables, right? And I'm going to have a constructor where you specify what the axis of symmetry will be. So this might be good practice to create constructors. So let's see, public square, and then string axis, right? And then you say this dot axis is equal to axis. So that's the format for a constructor, right? And then we say split across axis what we'll do is we'll say sys out control space on splitting the square across the, and then axis, so the vertical axis, the horizontal axis, the diagonal 1 or diagonal 2 axis. There are two diagonals, right, for a square, the axis of the line of symmetry. Yeah, and splitting across the vertical, and then plus where's my code? Okay, vertical or horizontal or diagonal axis. Yeah, so that's our square, right? And now let's create another graphic object just to, show you the, what, why we have abstract classes. So let's create a triangle. Actually, let's call it an equilateral triangle. Equilateral. Actually, no, not equilateral. Let's call it scaling triangle. And finish. And I'll say it extends graphic object. Add unimplemented methods. So another option that gives you over here, if you see, is make scaling abstract. Right, so if I make it abstract, I don't have to implement the abstract methods. It doesn't matter because I can't instantiate this, right? But I'm not going to make it abstract. What I could do is I could create a class called triangle. I could make that abstract, and then scaling triangle extends that. But I think that's too much of a stretch, and it will make the video unnecessarily long. So I'm just going to say add unimplemented method. So I'm going to say sys out drawing the scaling triangle. A scaling triangle is basically a triangle that where the sides are not equal, so all the sides have different lengths. I'm guessing everyone knows that, but maybe because in India, that was a triangle which has no equal sides was called scaling. Might be called different in other countries. So yeah, and I want to say sys, not system, sys out control space and print number of sides. Scaling triangle has 3 sides. So now if we had a triangle class which was abstract, right, but we implemented this, we wouldn't have to implement it over here. If the scaling triangle extended a triangle, right, we wouldn't have to implement this. So I don't know if that makes a lot of sense, but basically what I'm talking about is, you have your graphic. Let me comment that out. So you have your graphic object, right, and that is extended by a triangle, which is also abstract, right? Which is also abstract, right? And that is extended by a scaling triangle, right? Which is not abstract, non-abstract, right? So if in my triangle I had implemented this method, I wouldn't have to implement it over here. So just to get that clear, because the methods I have to implement in this one depends on the class I extend. It doesn't depend on this. It wouldn't depend on this. It would depend on this. So just to clear that up. Yeah. And then for this one, I'll say sys out scaling triangle has no axis of symmetry. I might actually make another video on this where I show you a full example, a complete example of abstract classes, where I have 2 levels of abstraction, and if this doesn't make a lot of sense to you, just message me and I'll do that. But yeah, so now you can see that the implementation for all these 3 methods is very different from the implementation for all these 3 methods. So in a square, we said drawing the square. A square has 4 sides, and for a square we could actually split across axis of symmetry. For scaling triangle, on the other hand, right, this is different, and it doesn't even have an axis of symmetry. But these two also share something in common, in that the way they're colored, the way they're enlarged, the way they're enlarged, and the way they're duplicated, rotated, and translated is the same. And that's really why we have abstract classes. You know, if we don't want, um, because they allow us to take the best of both worlds. They allow us to take the best of normal classes and interfaces. So yeah, and then one last thing is I'm going to have a main class. So main, right? And in this class, what I'm going to do is first I need the main method, right? And I'm going to create an object of I'm going to instantiate square and scaling triangle. So um, first one will be graphic object, and let's see, graphic object. Um, I'm going to have geo square, and you'll see why in a minute. I'm going to name it geo square. I'm going to do new, and I can't say new graphic object because if I do that, and if that was legal, right, then what would happen is if I said geo square dot geo square dot draw object, right, that wouldn't work because draw object is abstract at this level, right? And so it would be like, but I can't find any implementation, so what do I do for this, right? Like, and that's why you cannot instantiate an abstract class, because what if you call abstract methods, then there's no implementation, right? And so it will be like you cannot instantiate the type graphic object because it's abstract. So I'll say new square, and that works perfectly. So if we run that, hold on. Oh, okay. I have to provide the axis, right? I have to construct it properly. So let's say horizontal axis is the one that we want to split across. So drawing the square, right? On the other hand, if I had graphic object, and I'm going to say once again geo. Geo stands for graphic object. It's just an identifier. And scaling triangle, right? And if I said new triangle, for this I don't have to provide any not new triangle, sorry, new scaling triangle. I'm just going to copy that. I don't have to provide anything in the constructor because I don't have a constructor here. It's given a default one. Every class is given a default constructor if one is not created in the class. So yeah, so here I don't need it, but here I do, because remember we have to say what axis of symmetry we want to split across, right? So if I said geo square dot split across that, right? And over here if I said geo scaling, I'm going to do control space just so it fills it out, dot let's say draw object, right? Here's what it would print. So say drawing the square, splitting the square across the horizontal axis, right? Because we said horizontal over here, right? And then drawing the scaling triangle. Now, if in the scaling triangle we had a method called public void fold, yeah, and I'm just going to say this out, folding the scaling triangle, right? And this square, say I had a method called public void, what's a good method? I'll just say flip, right? And then I'll have this out, control space, flipping the square, right? And now over here, right, and to make note that these two methods, so flip is not in graphic object and fold is not in graphic object, right? So over here, if I said geo square dot flip, I can't do that. And the reason I can't do that is because geo square only has the methods that are under graphic object, and the way those methods are implemented are the way the implementation is written in square, right? And that's why geo square, right, cannot flip, because flip is not a method under graphic object. On the other hand, if I had a new square, right, but this time it points towards square, so it has all the methods that square does, right? And if I call this a square equals to a new square and say the axis of symmetry that we want to split across is vertical, right? And now I can say square dot, why do I keep misspelling that, square dot flip. So that works, but I can't say geo square dot flip. because that's a graphic object, right? So flipping the square. Similarly, with the scalene triangle, I can't say geoscaling, and I'm going to the control space dot what was it, fold? I can't do that, but I can create a new scalene triangle, and I can call the fold method on that. So if I said, let's copy that, scalene triangle equals to new scaling triangle, right? If I said scaling and let's do control space scaling triangle dot fold, that works, right? So if we run that, right, I can do that, but I can't do it on geo scaling triangle. So that was polymorphism that we looked at. That we looked at this format and polymorphism, but I wanted to show how polymorphism works with abstraction. So yeah, that's about it for this video. If you want me to make a complete example, if it would help you understand this better, just message me, and if a lot of people or even a few people ask me, I'll just make one, like an extended example. But yeah, that's about it for this video, and I'll see you next.